Yeah, you guys can all gather around if you want. I'm going to try to keep the eye down here. But this is a cow eye. Okay, this is a cow eyeball. And there's a lot more here besides the eyeball. There's a lot of tissue around it. And what you've got to do is really palpate around to find, to feel where the actual eyeball is at. And like I mentioned earlier, you know, the eyeball's tough. It's not going to pop. So you can be kind of aggressive at palpating around there. But let's try to identify some of this tissue around the eye. And yeah, so let's do that. What is some of the tissue that we find surrounding the eyeball? What does this tissue look like, this yellow tissue there?
Adipose tissue?
That's adipose tissue, that's fat. And why would we want a lot of fat surrounding the eyeball? It's for padding. Remember that the eyeball sits within the bony orbit. And so you need padding in there to protect it. Good. We have a lot of this. And keep in mind that these eyeballs are cut, you know, so some of this tissue got cut. But what does that look like? Looks like muscle. And it is muscle. What type of muscle is that? That's skeletal muscle. Those are the extrinsic eye muscles. So cows have extrinsic eye muscles. Maybe they hear a tractor with hay on it. So, you know, they turn that way to look at that, or, you know, maybe they hear a coyote or something, so they look over there, you know, up, down, you know, they're doing all the things they need to do to stay in the game. So we have a lot of adipose tissue around there. We have all of these external eye muscles around there. But yeah, and again, just palpate the eyeball. Kind of peel this structure away so you can find the eyeball.
Wow,
there it is. This is the anterior side of it. And so, you know, in the eye itself, there's fluid. There's aqueous humor, and in the back, there's vitreous humor that maintains the shape of the eye. And some of that fluid has been drawn out. And so that's why I'm able to, you know, poke on that structure, and it's able to give there.
I have a question. I would like to ask this. What kind of damage would we be doing right now to the front of the eye?
Well, I mean, this is a pretty smooth probe. So if your eye was forced open and somebody, you know, gently ran it across that, it may not scratch it. You know, what you're worried about is scratching of the cornea.
But it would still be extremely uncomfortable.
It'd be uncomfortable.
Painful,
It would be uncomfortable.
Too.
Okay. So what is this structure that I'm pointing at right there?
Cornea?
That's the cornea. Good. And if you look through there, you can, well, we'll save that, but you can see some stuff through there. Now there is some connective tissue around this, but you can kind of get into the white of the eye. The cornea is continuous with the white of the eye. And what do we call that white of the eye? That's the sclera. Good. Okay, this is the anterior side of the eye. And in the back, if we palpate around, this is a posterior view of the eye. We have this little nubby structure in the back. What is that? That's the optic nerve, cranial nerve 2. Good, so once we've identified all these structures, what we want to do is remove the excess connective tissue around in it. And it's been a while since I've done this, but you know, it's just kind of like riding a bike, or in this case, peeling an orange. And what you want to do is kind of get your fingers around the eyeball so you don't cut into the eyeball. And then we just want to take these scissors and work your way around the eye and try to get as much of this connective tissue, this fat in particular,
kind of damage would this be
Oh my gosh.
You know, you can clean up the back too, peel some of this away. Done a few of these, so, you know, it's a little bit of skill here. You said it, not me. And the reason I like to clean up the back, yeah, you can really
What
start.
about the gland? You're not able
You know, glandular tissue, when it's preserved, is kind of hard to identify. I'll bet you we could, if we palpate or if we look around in here really closely and we kind of know the general area, maybe we'd find the lacrimal gland, but it's kind of tough to find. So here we go. Here's our actual eyeball, and you know what I really wanted to do was reveal that structure in the back to reveal that optic nerve. And again, it's been cut, but that optic nerve continues. It passes through the optic canal in the sphenoid bone. It goes into the skull, crosses over at the optic chiasma, and then it becomes the optic tract, which goes to the thalamus, which then sends that information to the occipital
When they
lobe.
cross, do they like interact with each other, or are they by themselves, like stacked on top?
The neurons, it is one structure that they're not stacked on top of each other. That's a good question. They become the same structure.
There, it's like, okay.
And then some of those neurons pass one way, and some of those neurons pass another way out of that chiasma.
Like, one goes to the complete opposite side, all the
Yeah.
picture goes to the opposite side,
Mhm.
or intertwined.
Yeah, that's why they should have a facility
Yeah.
and they get to because
So now what we want to do is get inside the eye. And because the eyeball is such a tough structure, this is going to require a scalpel blade, and a sharp scalpel blade. Again, some of this, the ocular pressure inside this eye is really low because some of that fluid has gone out in there. So when you're puncturing through the eyeball, and specifically through the sclera here, I like to give it a little bit of a pinch to put some pressure on there. And what I want to do is just go outside on the sclera a little bit. So here's the cornea, and just get into the sclera region and give yourself a little bit of room. And what I want to do is make a little incision through there. There we go. Okay. And then if you have a sharp pair of scissors, which some of ours are, maybe not this particular set. I'll be right back. I'm going to try to get a sharper pair of scissors.
This could be so fun.
I'm so excited.
Toss those. Again, what we want to do, a little better, is complete that incision, complete that circle. Around the eye. And if you can, it's helpful to use the base of the blades here instead of the tips. Try to get in there at the base. You just have more cutting power. And at that point, I can pop off the front of the eye. So now we have, okay, we're looking at two different things here. Let's look at the posterior portion here. So this is behind the lens. And the area behind the lens is collectively called the posterior segment. And this big, large area in there is not empty. Okay, it's filled with fluid. and it's filled with this jelly-like fluid. Anybody know what we call this jelly-like fluid? That's the vitreous humor. Okay. So what I'm going to do, is try to take that vitreous humor. There it goes. There's your vitreous humor.
Is that the actual consistency it is, or is
Pretty, it's a jelly-like consistency. Yep, yep. Now, what's the purpose of the vitreous humor, would you imagine? I can think of two reasons why that vitreous humor is important. Well, one, it helps maintain intraocular pressure inside the eye. And the other thing that it does is the retina on the back of the eye is really delicate. And so it pushes that retina and keeps it intact up against the back of the eye. I think we'll come back to this. There's the cornea, and again we made an incision, so now we're looking at it from the back. And you have some vitreous humor that's remaining, and I'm just going to take this probe and just kind of get rid of some of this vitreous humor, clean it up a little bit. Good. And what's that? That's the lens. And here we have this band of smooth muscle around the lens, and you can see it has these striations in it. What did we call this, this dark band of smooth muscle that's surrounding the lens? That's the ciliary body. And that's smooth muscle, and it can contract and relax, and when it does that, it has ligaments that pull on the lens, and it can change the shape of the lens. Now what I'm going to do next is pop out this lens, but before you do, I want you to take a probe and take it in between the lens and the ciliary body, and you'll be able to pull up on these ligaments that connect the two. So you can do that, and they're not super strong. You can break them. Ooh, yeah, there they are. But then eventually what I want you to do is break those ligaments. Pop out that lens. Okay. Now this may be difficult to see, but there's actually two layers going on here. We have this outer ciliary body, and then we have another layer that's internal to that. And the reason you weren't able to see that prior is because the lens was on top of it. So the outer layer is the ciliary body. What do you think this, this inner layer is, which is also smooth muscle? That's the iris. That's the colored portion of the eye. And it's tough to see here because the cornea is clouded, but you'd be able to see the iris, you know, whatever color that, that cow's eyes are. And then in the middle of the iris, we have this hole, which is called the pupil. Good. Ciliary body, iris, pupil. Cornea. So light goes through the cornea, through the pupil, through the lens, through this jelly-like vitreous humor that is contained in the posterior segment. And then finally, that light information hits the retina, the inner layer of the eye. And the retina is really, really delicate, but it's this cream-colored layer in the back. And if you're really careful, you can take a probe. Oop, I got both the, let me see. There we go. And you can pick up that retina. This cow now has a detached retina. There it is. All right.
What would a detached retina do? Would that be blindness?
Yeah, I'd imagine so, because it's you know, detaching photoreceptors from other neurons that are gonna take it where it needs to go, or at least do damage to those photoreceptors, I imagine. Then in the back of the eye, you can see where there are these kind of wrinkles, and then it looks like a little exit at the back of the eye. What is that little? What is this little dot where the retina is kind of leaving the back of the eye? That's the optic disc, also called the blind spot. Good. And right in back of the blind spot, guess what? Is the optic nerve. All right, so that's a lot of it, but you can detach the retina. There you can see it detaches easily, except where it leaves the back of the eye. Okay, and then you get into this next layer, which is called the choroid layer, and you can actually detach the choroid from the sclera really gently. There you go. That's the choroid layer. And the choroid layer is highly vascular. A lot of blood vessels going through there. And then that allows you to also see to identify the sclera, the wide of the eye, which is a lot tougher. Now, something cool is going on with this cow eye that isn't found in a lot of mammals. What do you notice about the choroid back here? You have this nice kind of opal-esque coloration to the back of the eye, and that's called the tapetum lucidum. And you find the tapetum lucidum in particular in nocturnal animals. I don't know if ancient cows were nocturnal, you know, or whatnot, but you find that in nocturnal animals, cats, deer. And what happens is that when light comes in, it passes through the retina, but then that light gets reflected back by that tapetum lucidum. And so it gives the photoreceptors a second chance to process that light.
Is that why when you like shine a light at like cats, they're bright?
Absolutely. It's the tapetum lucidum.
That's so cool.
Yeah, it's the tapetum lucidum.
That's crazy.
Okay.
So if we cut that and like from the middle, from the blind spot out, will the retina be connected to the nerve in the back?
Yes, the retina is connected.
It's weird how it just-
This one's weird. It's like it's exiting in two locations, which is funny. But yes, the retina is connected to the nerve right in back of it.
just goes straight through.
Goes straight through. Yep, out the optic nerve.